There's a version of enterprise AI that works. The agent understands what revenue means in your organization, it knows your fiscal calendar, it knows which data sources to trust when two tables disagree. And it knows this consistently across every query, every session, every model upgrade, every new agent you deploy. Then there's the version most enterprises are actually building. They give coherent answers, some of which are correct. The ones that aren't are wrong about business logic, not syntax. The difference is architectural. It turns on one distinction most practitioners conflate: the context window and the memory layer. That's what this guide is about. Data teams spend months on AI pilots that work brilliantly in demos and fail quietly in production. The gap is almost never the model, it's almost always context. Specifically, the assumption that if you retrieve enough documents or write a detailed enough system prompt, you've solved the context problem. What most teams actually need to understand is why that approach hits a structural ceiling and what the architecture looks like when we build past it. Let's start with the mechanics, because the context window is genuinely misunderstood. Not in a practitioners don't know the word way, but in a practitioners underestimate the structural constraint way. Every large language model processes input as a sequence of tokens, pieces of text that might be a word, a syllable, or a punctuation mark. The context window is the maximum length of that sequence. Whatever is in that window when the model runs is what it has to access. Your instructions, any retrieved documents, conversational history, business definitions you've included, and any examples you've preloaded. That's it. When the session ends and a new one begins, the window resets. The model has no memory of the previous session except what the application layer explicitly reinjects. Now, this isn't a bug, it's a property of how transformer-based models work: a single forward pass over a finite input sequence. The window can be made larger, though. GPT-4 supports 128,000 tokens. Gemini 1.5 Pro supports 1 million. But larger windows change the quantity of the constraint, not the nature of it. Three things remain true regardless of the window size. First, the window resets. 1 million tokens of context goes to zero at the end of the session. Everything injected needs to be re-injected next time. Second, filling the window is expensive. At production scale, thousands of queries a day across dozens of business units, the cost of injecting a large context on every single call isn't academic. It's a line item that grows linearly with usage. Now, third, and most importantly, size doesn't solve quality. A Databricks study on metadata enrichment found that propagating clean, structured metadata produced a 70% quality improvement in AI retrieval, not from a larger window, but from better organized context. And a study on auto-generated context files, agent markdown files, populated automatically and injected into agent sessions, found that more context but poorly curated actually reduces task success rates compared to less context that is well curated. Volume does not substitute for governance. So prompt engineering and RAG are both working within this constraint, not around it. Prompt engineering optimizes how instructions are phrased inside the window. RAG retrieves relevant documents and inserts them before each request. Both are valuable techniques. Neither creates persistent, accumulating governed organizational knowledge. They're tactics for making the best use of a temporary space. They aren't a substitute for a different architectural layer entirely. Building on that foundation, we can now be precise about what kind of context an AI agent actually needs to answer business questions reliably. Because the context window problem isn't just about how much context fits, it's about what kinds of context exist and which ones most enterprise AI projects are entirely missing. Now, there are 4 levels, and they aren't equal in how often teams think about them. Data context is a level most teams address: which tables exist, which columns contain what, lineage showing where data came from, quality scores signaling whether a source is trustworthy. This is the metadata layer that data catalogs have been building for years. Most enterprises have partial coverage here. Meaning context is the layer most teams underestimate. Revenue is a column name. But what does revenue mean in this organization? Is it recognized revenue or invoiced revenue? Does it include refunds? Does the definition differ between the sales org and the finance org? When an AI agent picks a definition at random or inherits a generic one from the model's training data, the result is an answer that's structurally correct and semantically wrong. Articulate, plausible, but wrong. Knowledge context is a layer that walks out the door when senior analysts leave. Business rules, fiscal calendar logic, exception handling. We don't count closed deals in the first 14 days of the quarter as Q4 wins. The EMEA label refers to the sales team, not a geography. When the editorial system and the warehouse mirror disagree, trust the editorial system. This knowledge isn't in any schema. It lives in the heads of people who have been there long enough to know, and it evaporates when those people move on. User context is a layer that determines that the same question asked by someone in finance and someone in marketing should get different answers. Not because the data is different, but because the relevant definition, the relevant access permissions, and the relevant decision context are different. Now, let's make this concrete. A media company builds an AI agent to answer questions about content performance. A producer asks, "What are our top 10 political shows last quarter?" Without data context, the agent doesn't know which table to query or whether the numbers in it are actually reliable. Without meaning context, top 10 might mean views, but the actual definition in this organization uses watch time, and for content under 5 minutes, it switches to views. The agent uses the wrong metric. The list is wrong. Without knowledge context, last quarter maps the calendar quarter. But in this organization, the fiscal Q3 ended 6 weeks ago, not 3 months ago. The date range is wrong. Now, without user context, a producer and an advertising sales marketing rep asking the same question should see different cuts of the data. The agent treats them identically. Each failure is invisible from the outside. The answers look right, it's returned confidently, but it's wrong in ways that a human analyst, one who had been there for 3 months, would not make. Most enterprise AI pilots address data context and stop. The other 3 layers are where production failures actually live. And this is the problem that a memory layer is designed to solve. Now that we understand what types of context exist and where they break down, we can look at what a memory layer actually is and why it's a categorically different kind of infrastructure than a context window, not just a larger one. The simplest way to frame it, a context window is a workspace. A memory layer is the organization's world model. One is temporary, the other compounds. We can think about the difference between a new analyst's first week on the job and the institutional knowledge of a 20-year veteran. Both can access the same data. The new analyst reads the documentation, runs some queries, asks colleagues questions. By month 3, they understand the fiscal calendar. They've learned which sources to trust. They know which business rules have exceptions. That accumulated understanding, the world model that they've built, is what makes their answers reliable. And critically, that world model doesn't reset after every conversation. It persists, it deepens, it incorporates corrections. The context window is the analyst's first week, repeated forever. It can be filled with good things, but it starts from zero every time. The memory layer is what the 20-year veteran has built up, and it does not reset. But here's where the analogy needs one more step, because memory layer can sound like a database, and that framing misses the most important property. A static knowledge base stores things. A memory layer improves with use. This is the flywheel, and it's what makes the memory layer a strategic asset rather than a feature. An agent interacts with a user. The answer is wrong or incomplete. That failure traces back to a specific context gap, a missing business rule, an ambiguous term definition. A domain expert corrects it in a governed workspace. That correction propagates. Every subsequent interaction by every agent that draws from the same memory layer benefits from that correction. The memory layer gets more accurate with every cycle. This is precisely what makes the memory layer a compounding investment, and it's why context has become the layer in the AI stack that organizations should care most about. Models commoditize. GPT-4 costs collapsed by 99% in 18 months. Orchestration frameworks are open source, but the organizational world model, the governed, accumulated, continuously improving representation of what our data means, who owns it, and what our business rules are, that's built by your organization, specific to your organization, and it gets more valuable the longer you invest in it. The governance dimension here isn't optional. Context without governance creates a different kind of AI failure. If anyone can modify a business term definition without accountability, if there's no versioning, if revenue has three competing definitions and no certification process to resolve them, then a larger memory layer makes agents more confidently wrong, not less. The archive evidence on auto-generated context files makes this point empirically. More context, poorly curated, reduces task success rates. Governance, accountability for accuracy, certification, version control, access control, is what converts storage into a trustworthy knowledge system. The memory layer, then, is three things simultaneously: a persistent organizational world model, a governed learning system that improves with use, and a portable infrastructure that any agent in the organization can draw from, regardless of which model, which vendor, or which application is doing the asking. With that foundation established, we can look at what building and governing a memory layer actually looks like in practice, and how Atlan's architecture maps to the conceptual layers we just described. The starting point is always the same. We can't engineer context from nothing. The raw material is the metadata that already exists across the organization's data stack: schemas, query history, lineage, pipeline code, PI semantics, quality signals, business glossary entries. The foundation is Atlan's enterprise data graph: 80 plus connectors pulling from warehouses, BI tools, pipelines, and quality tools into a single living graph. Column level lineage, SQL query history, and data profiling are the raw signals that tell you where data came from, how it's used, and whether it can be trusted. This is the foundation. Without a populated data graph, context engineering can't begin. There's no structured signal to build from. The next layer is automated enrichment. Context Agent Studio provides three agent types that work systematically across the asset graph. The description agent analyzes table and column names, lineage, and query patterns to generate business meaningful descriptions. Not restatements of column names, but descriptions that explain what an asset is for, what it contains, and how it's used. The README agent generates higher level documentations covering purpose, usage patterns, and pipeline position. The SQL Intelligence Agent surfaces popular joins, common filter conditions, and recurring business questions from query history and registers these as key metadata on the relevant tables. Those agents operate on collections, groupings of assets built automatically from usage signals like query logs, lineage, BI activity. Default collections include things like popular SQL assets, gold layer assets, and assets connected to data quality monitoring. A critical behavior worth noting: agents only enrich assets that are missing the target attribute. Existing human-authored descriptions are never overwritten. The automated layer fills gaps. It does not replace human judgment. But automated enrichment addresses data context primarily. Getting to meaning context and knowledge context requires a different kind of work: semantic model engineering, which is what Context Engineering Studio is designed for. The workflow begins with a use case. Not enrich all tables, but make the sales AI analyst reliable for RevOps. From there, the relevant assets are identified, specialist agents handle the initial enrichment pass, and the output is a structured context model rather than a loose collection of metadata fields. The critical step is simulation. Rather than testing the agent against an infinite space of possible questions, they're automated evaluation sets. If the AI agent can correctly answer every question that a current dashboard already answers, it has passed a meaningful definition of done. This is how organizations escape testing hell, the 6 week, 6 month loop of accumulating test cases with no end in sight. Human refinement happens in bounded context spaces, scope workspaces where domain experts can contribute and correct the tacit knowledge that automated enrichment can't capture. The RevOps team corrects the fiscal calendar logic. The data owner certifies the definition of closed won. The knowledge context layer is built not by AI alone, but by the people who hold the institutional knowledge that makes business answers trustworthy. Once the memory layer is built and governed, it needs to be reachable by any agent that draws on it. This is where the universal context layer and MCP integration for Atlan become the connective tissue. The context lakehouse is built natively on Apache Iceberg, an open portable format, and is queryable by any AI agent via MCP or SQL. The significance of the open format is not incidental. It is the architectural decision that prevents context lock-in. Context built in Snowflake's Cortex doesn't transfer to Databricks. Context built for one AI vendor's format requires rebuilding when the organization switches models or adds a new agent. By building the memory layer on open standards, we make the organizational world model portable across the entire AI stack. Every agent, every model, every vendor, drawing from a single governed source of truth. Data leaders we work with put it directly. All the work they've done to establish a shared language across their organization can now be used by AI via Atlan's MCP server. The world model was already built. The MCP connection is what makes it available to AI without rebuilding it per agent, per vendor, per model generation. This also is the answer to the 5-agent fragmentation problem. When an enterprise has deployed 5 AI agents over 18 months, each built by a different team, each with its own definition of customer, revenue, and active contract, the symptom is conflicting answers. A customer service agent says 3 active contracts. A procurement agent says 2. Neither is wrong given its own partial context, but users lose trust in both. The fix isn't better individual agents. It's a shared memory layer that all agents consume from. So the definition of active contract is a certified one, a governed one, and consistent everywhere. The compounding flywheel closes the loop here. Production usage generates feedback. Feedback identifies context gaps, the places where agents return wrong or incomplete answers. These gaps surface to domain experts as refinement tasks. Corrections are made in governed workspaces. Those corrections propagate to every agent drawing from the shared context layer. The next generation of interactions is then better. And the organizational world model, unlike an individual context window, keeps accumulating, keeps improving, keeps compounding. The core shift this guide represents is architectural. Stop thinking about context as something you inject before each query, and start thinking about it as something you build, govern, and compound over time. The context window will always reset. The memory layer doesn't have to. The natural next question is, what does it actually take to bootstrap a memory layer from a cold start when descriptions are sparse, business terms are undefined, and no one has time to write documentation? That's exactly what we cover in the Context Agent Studio walkthrough, linked in the description below.